Welcome dear students. Today our lecture is about water conservation. In our previous lecture we talked about energy conservation and we tried to sort out methods and processes through which energy conservation can be achieved. Now in this today's lecture we will be covering this topic of water conservation. Again it is a very broad topic and it's not possible to cover all the aspects of water conservation, but still we will try to touch all the aspects so that you can have an idea how we can actually adopt water conservation in different industrial processes and in our social uh, utilities and in social and in our society. Just to remind what our target is in our cleaner production techniques, we are going to focus uh, such a technology which is economical and at the same time it is environment friendly. So our more focus is supposed to be on the renewable energy and recycling of water so that the water which is already in shortage should be maximum utilized and such processes should be encouraged through which the minimum utilization of water is required. So first comes the water management in society, and under this heading we will be studying global perspective, then water use in industry, integration of industrial and water management, provision of water to industry. So the purpose to write all the things here was to give you an idea what in this lecture we are going to focus. First of all, our focus is to understand the availability of water and the stress level which water is facing nowadays and different processes. So, considering the global perspective, there is an uneven distribution of water over the world, and you can justify this by our global warming effects. Especially if you see that the rainfall pattern has completely changed. If you obtain the data of last 50 years of any region, you will observe a very obvious change in the temperature variation as well as its uh, duration variation. So the time taken by the time which was earlier used for rainfall is no more existent. Sometimes in the area where there was drought conditions, where there was uh, a very less amount of rain, now the rainfall pattern has changed. Now there is a huge amount of rainfall in areas. Kind of uh, unbalance is uh, registered due to the observed due to the global warming impact. So this is normally expressed in terms of climate change. And if you again focus that this pattern is not consistent, this is changing region to region. Somewhere at some places there is huge rainfall, somewhere very minimum rainfall, somewhere uh, more durations for rainfall, somewhere minimum durations of rainfall. So it's continuously changing. Even in your region where you are living, If you observe the data for the last 10 to 20 years, you will observe a very prominent change. So, due to this overall impact, you can observe that our water resource has completely shifted. So earlier, where there were a huge amount of water resources available, now the water availability has reduced to a much lower level. So then this is all due to the climate change and its impact. Now, if you see the availability of water, it depends on yearly runoff and the amount of the precipitation. So what is precipitation? So one thing is rainfall and the other thing is precipitation. Can you differentiate between rainfall and precipitation? Rainfall is the measurement of rain in the form of water, while precipitation is uh, uh, any kind of addition to water resources, which can be through snow, which can be through haze, which can be through water vapors. So it's a broader term, precipitation, which covers distinct uh, sources. So then, to improve and limit water management is one of the main priorities of this century, because you have observed that our some of the regions with drought conditions have to suffer. So we should try to manage water in a much more appropriate manner. There should be some water saving schemes and such schemes with which lesser water is used. So like in Africa, Middle East, China and arid and semi-arid areas, a water access crisis is already a reality. So because water is not available, so it is difficult to access water. The challenge is instead to improve water quality in rivers and lakes. Availability of water depends on yearly runoff, that is the amount of precipitation. Water use is very different in different parts of the world. On the global level, irrigation and agriculture account for the largest share, about 65%, followed by industry 24%, municipal needs are 7%, and in storage reservoirs is 4%. This is, I think you are very well familiar with this figure. We studied it in our previous course as well. But it is so important that I want you to uh, have a good knowledge about that where our water stands, where are our water resources available. So please, it's my request to thoroughly go through this slide. And it is very comprehensive, understandable, and it is very much required. It will give you a very general and good information for your future works. So you see that 97% water is in oceans, 3% is fresh. Out of this 3%, we have 68.7% capped in ice caps and glaciers, and 30.1% is in groundwater, and the leftover is surface water in the form of 0.3, which is rivers and lakes, and the other, which is like biosphere and plants and water vapors, it is about 0.9%. Now if you see about this surface water, which is 0.3%, out of this we have lakes 87%, swamps about 11%, river about 2%. So this is the whole scenario which is very clearly described in this picture. Please go through it again and try to grasp and understand where do our water resources exist. And it is again the same thing. And I think you are again well familiar with the hydrological cycle. In our previous course, if you remember and if you recall, we focused on the uh, environmental system in which everything is in the form of a cycle, moving from one sphere, traveling to the other, and then again to the third sphere, and then into the fourth sphere. We studied four spheres, and water is traveling in all these spheres in one shape or the other, one form or the other. So these are some of the possibilities and of the hydrological cycle, how water travels in different and water bodies and in different spheres. Water availability in Pakistan, again, this question is very alarming because gradually the water availability is becoming most of the reason is the mismanagement of the water resources. It is not like that we are lacking water, but we are lacking management. In our coming slides, we will uh, try to understand how this phenomena is actually occurring. So again, the occurrence of fresh water, where is it available? So in surface water, in groundwaters. So these are the basins. If we have major Indus River basin, and in addition to this, we have some other basin as well. So this is something about the rivers. Please, it is again a very valuable data. I will request you to try to remember uh, what are our water resources, how do they exist, where they are available. These are the other basins available in our country other than Indus River Basin. So Haran Desert Closed Basin, Bishin Basin, Makran Coastal Basin, these are the other available basins. Well, again, this is how the water reservoirs are being replenished and how the water infiltrates and how the groundwater uh, replenishes and accumulates water and how the water travels in the subsurface. All these things are just kind of a repetition, and because of their significance, I have added these slides in this course because I want you to have a good understanding about phenomena, particularly water resources and how the water accumulates and how the water moves and what's the quality of water available and what is actually the climate change and how it is impacting our water resource reservoirs. So all I want is you to get a good understanding. So again, it's kind of repetition. Please go through these slides. It's a very important slide once again. If you see there are some barrages and linked canals and main canals and water courses and all dams, barrages, headworks, all the data available here is related to our uh, country. So please go through these data information. These are the reservoir groundwater resources and how much water is available. So Punjab is having the maximum groundwater resource 43.2 million acre feet. Sindh 18.4, Balochistan 2.1, KPK 3.1. So quite an old data, but giving you a general scenario where the water is existing. And again, in Balochistan and KPK, you can see the water in groundwater is very much limited. We have more water in Punjab in groundwaters, and then secondly we have in Sindh. It is totally dependent upon the soil profile and subsurface strata, what kind of situation there is underneath and what kind of available geological formation is there in the subsurface so that water can get stored and move, the most important. In KPK, water is mostly in the form of confined aquifers. It has a certain type of geological formation which is going to lock the water boundaries and create a confined environment. So this was something again about the groundwater resource. Basic water requirement standards for human need is 50 liters per person per day. This includes drinking, bathing, cooking, and maintaining the hygiene. So, then rural household water use by climate, and then we have some water intake recommended is here. The recommended intake minimum for under routine conditions was 2.9 liters per day. So this was just for your information about the general requirements of a human body about the water. So what are the impacts? You can see here, this is all about the climate change impact. We have gone through it previously, just to emphasize. These are the floods. These are the situation. This is how the climate is changing. This is a very uh, typical example of our climate change phenomena. So Pakistan is already a water-stressed country with around 1038 meters per capita water available, a drop from 5,000 cubic meters in 1951. So in that time, 1951, uh, if you assume that Pakistan, this was West Pakistan, we had East Pakistan as well, and we had almost double area to irrigate, and based on this, our situation now has become more worse. So just to give you an idea, so again, this is something about our country, and we are using at least 10 times more water than the water world's average. And at the same time, at what price we are obtaining our water, it is almost free. We have very limited amount of pricing and billing about water. So it is almost free, and still we are using it 10 times more than the whole world is doing. So same if you look at Faisalabad data, we are having about 100 million gallons every day provided by Wasa, and it is uh, uh, provided to 900,000 people, and it's giving an average of 100 gallons per person per day. So there may be some issues with the population, but Vasa has a very much controlled system, so they know up to how much persons and how much people are utilizing their services of water. So in this term, you can say that the water provided by Vasa is quantified, and it is more reliable documented figures about the population which they are serving. So just on an average, if you get this idea, that on an average of 100 gallons per person per day is provided. Then we have some utilization in industry, because you know that our previous graph we found that about 24% of the water industry. So water consumption in society has decreased significantly over a period of some 50 years. Overall, we are talking in other countries and worldwide level. And finally, there is decrease discharges of wastewater and facilitate the recovery of chemicals and energy. So this is how the world is dealing with this water scarcity issue. They have limitized their water usage. Maximum consumption of water has been adopted, and water conservation strategies have been adopted so that the water can be saved at all the levels in industry and in society both. And furthermore, the availability of water has also been ensured to all the stakeholders. Furthermore, it has an impact on reduced wastewater production generation, sorry, and because of that, our treatment cost has also decreased, and at the same time, the recovery of chemicals and the recovery of energy from that wastewater has also increased. So it is kind of maximum utilization of available resources. Maximum utilization of available resources. So even water is less, but still they have utilized it in such a way that their needs are sufficiently met, and at the same time they are properly uh, exploiting their water resources, and they are supplying it to every area, every content of the stakeholder uh, serviced by. Yeah, there is a requirement of the integration of industrial and municipal water management. So if you consider industrial water handling and solid waste treatment, and municipal water and solid waste treatment, they are very much interlinked. So they have common utilization of treatment facilities and supply sources, and then uh, the residual product flow, which the treatment at its own is available in industrial water, and then options for industry to adopt integrated approach. At manufacturing stage, to influence amount and properties of residual products flow, it is important that there should be a well-balanced system. The more we integrate the wastewater and its recycling, we can reduce uh, the effluent emissions. Large scale reduction body emissions from different industries like paper and pulp, sugar. Large reduction in organic chlorine compounds. So this is the result of integrated approach. We need to link the domestic and the industrial usage of water. So maybe water coming from domestic source has lesser uh, chemicals, and lesser treatment is required, and we can easily treat that water, and we can easily reuse that water for our industrial purpose. So this is called integrated approach. So now I will see a graph with the help of which you can understand how much emissions have been reduced. If you see BOD being the major emission, उसमें अगर आप ऑब्जर्व करें that in this Baltic region, Swedish country, the data provided is like this. 1950 से लेके 1997 तक, you can see a change in the emissions of gradually the BOD emissions has reduced. And what is the reason? Emissions of biodegradable compounds. Uh, so this is because of the integrated the sources from domestic wastewater are being industry, and at the same time within the industry there is a recycling process. We have different types of wastewater की different sources हैं. हर प्रोसेस जो है वो वेस्ट वाटर जनरेट करता है, और हर प्रोसेस की जो वेस्ट वाटर की करेक्टरिस्टिक्स हैं वो डिफरेंट है. सो दे नीड डिफरेंट ट्रीटमेंट. कुछ जो प्रोसेसेस हैं उनमें ज़्यादा केमिकल रिलीज होते हैं, कुछ में कम रिलीज होते हैं. जिनमें कम रिलीज होते हैं उनको हम बहुत लो कास्ट के ऊपर ट्रीट करके रिसाइकल कर सकते हैं. सो दिस इज द पॉसिबिलिटी विच इज बीइंग अडॉप्टेड इन आवर इंडस्ट्रीज. आगे चल के अभी हम देखते हैं व्हाट आर दी वेस्ट वाटर टाइप्स, और वो जो टाइप्स हैं वो किस तरह से बेनिफिशियल हैं अगर हम उनको सेपरेटली डील करें. तो एट द सेम टाइम अगर हम एक तरफ इंटीग्रेशन की बात करें तो उसी वक्त हम सेपरेशन की बात भी करें. वेस्ट वाटर नॉर्मली जो ट्रीटमेंट प्रोसेस अडॉप्ट करते हैं उसमें सारे का सारा वेस्ट वाटर जो है इट इज़ एक्यूमुलेटेड. आगे जाके इसको मज़ीद एलेबोरेट करते हैं. So industrial water handling has several connections. ये हमने अभी go through कर लिया, आप इसको go through कीजिए. So provision of water to the industry, उसके surface water is better, ground water is better, waste water reuse जो है उसकी क्या possibilities हैं, for areas with restricted supply जो है वो कौन से हैं, and what are the aesthetic problems. इनफ्लो जो है वो इरेगुलर होगा, उसके क्या जो साइड इफेक्ट्स हैं, हाउ इट इज गोइंग टू इफेक्ट इकोनॉमी. नॉर्मली जो बैच फ्लो है वेस्ट वाटर ट्रीटमेंट प्लांट के अंदर, उसकी वजह से जो फ्लो इनफ्लो है वो इरेगुलर होता है. उसको हम बैलेंस करते हैं बाय फ्लो इक्वलाइजेशन, बट इट इज नाउ इन ऑब्सोलीट मेथड. हम अभी जो है वो एक कंटिन्यूस रिएक्टर की तरफ मूव कर गए हुए हैं. हम ज़्यादा रिलाई नहीं करते हैं बैच प्रोसेस के ऊपर, बिकॉज वी हैव एन इमेंस क्वांटिटी ऑफ वेस्ट वाटर फ्लोइंग इनटू द ट्रीटमेंट प्लांट, और उसकी वजह से वी आर सपोज टू हैव अ कंटिन्यूस रिएक्टर. कंटिन्यूस फ्लो रिक्वायर्ड है ट्रीटमेंट प्लांट्स के अंदर. वी कैन नॉट अफोर्ड दिस irregular this batch processing in the wastewater treatment plants. So इसमें अगर आप देखें कि कौन सी जो प्रोसेस है वो कितना वेस्ट वाटर प्रोड्यूस कर रहा है. सो उसमें आप देखें इंडस्ट्रियल वाटर यूज जो है स्वीडन के अंदर, we have cooling water for electric power generation and other cooling water. मतलब different processes के अंदर जब cooling water adopt करें वो maximum water जो है वो consume करता है. and then second number पे हमारे पास process water जो है वो आ रहा है, फिर sanitary water जो है, and then other water use, non distributed water usage. so यहाँ से ये आप समझ जाते हैं चीज. Volume wise cooling water dominates followed by processed water. आप यहाँ से देख सकते हैं कि जो कूलिंग वाटर है ये मैक्सिमम जो है वो यूटिलाइज हो रहा है. ऑलमोस्ट ऑल ऑफ द वाटर इज विदड्रॉन फ्रॉम सरफेस वाटर, जो कि लेक्स हैं, रिवर्स हैं, एंड इन अ फ्यू केसेस वाटर जो है उसको हम यूज करते हैं आफ्टर द डिस्टिलेशन. ग्राउंड वाटर रिसोर्सेज आर thus not exploited for industrial purpose. ये एक बहुत ही जो है पॉजिटिव चीज है, बट nowadays it has been observed industry is using groundwater resource, so which is totally unacceptable, because water groundwater resource must be balanced, must be uh, must not be exploited. Even कि जो हम irrigation purpose के लिए exploitation करते हैं through pumps and especially private pumps, even it should be not allowed. We are actually unbalancing the available water resource. This is the only water resource which is considered to be safe and unexploited. But when we are going to use it, our water level is going to reduce, which is going to have an impact on overall water balance. So इसलिए जो आप ऑब्जर्व करें, हमारा जो प्लेन एरियाज है पंजाब के, वहाँ पे वाटर लेवल इज एट वेरी हाई, एट हाई लेवल, और हमें चंद मीटर्स के फासले पे ही ग्राउंड वाटर अवेलेबल हो जाता है मोस्ट ऑफ द केसेस. बट ड्यू टू द ओवर एक्सप्लॉयटेशन हमारा जितना भी वाटर है वो उसका ग्राउंड वाटर, उसका लेवल जो है, वाटर टेबल लेवल जो है, इट हैज सिग्निफिकेंटली रिड्यूस्ड, जो कि टोटली अनएक्सेप्टेबल है. स्पेशली अगर आप ऑब्जर्व करें कि अगर हम इंडस्ट्री के लिए भी अब जो है वो ग्राउंड वाटर रिलाई करेंगे तो इट इज totally unacceptable. It is going to create a havoc. We must resist to use groundwater for all any such purpose. हमारे पास बहुत सारी और ऑप्शंस हैं इंडस्ट्रियल प्रोसेस के अंदर वाटर को यूज़ करने की. द मोस्ट इम्पॉर्टेंट इज कि वेस्ट वाटर को आप ट्रीट करें, उसको रिसाइकल करें. प्रोसेस, डिफरेंट प्रोसेसेस में जो वाटर हम डिस्चार्ज कर रहे हैं उसको रिसाइकल करें. बट इट इज़ नॉट एक्सेप्टेबल कि आप ग्राउंड वाटर को यूज़ करें. सो ये वही चीज़ें आप प्लीज़ गो थ्रू कीजिए. नाउ it's about measures to reduce water consumption. So there are different processes, strategic choices and separation of different kinds of wastewater. ये वो चीज़ है जिसकी अभी हम थोड़ी देर पहले जिसको डिस्कस कर रहे थे कि हर प्रोसेस इंडस्ट्री के अंदर वेस्ट वाटर जनरेट करता है और उसका जो लेवल ऑफ कंटेमिनेशन है वो भी डिफरेंट है. सो उसकी जो ट्रीटमेंट रिक्वायर्ड है वो भी डिफरेंट है. सो we can easily treat less contaminated water and we can easily recirculate that water for different water purpose. अभी हमने देखा कूलिंग प्रोसेस, फिर cooling water, process water, वो कि how immensely water is being used. So अगर हम इंडस्ट्री के अंदर भी रिसाइकलिंग यूनिट्स लगाएं और पानी जो उसके अंदर रिलीज हो रहा है उसी को रिसर्कुलेट करें, then how much water can be saved. So this is one of the major options ताकि हम वाटर कंजर्वेशन की तरफ जा सकें. So these are the different sources जिससे वाटर वेस्ट वाटर प्रोड्यूस हो रहा है. प्रोसेस वाटर है, कूलिंग वाटर है, सैनिटरी वेस्ट वाटर है, स्टॉर्म वाटर है. ये सारे वो सोर्सेज हैं जहाँ पे वाटर कंज्यूम हो रहा है एंड देन इट इज बीइंग रिलीज्ड, बिकॉज इसने सिर्फ उसके अंदर सर्कुलेट करना, स्टीम प्रोड्यूस करनी है एंड देन इट विल बी अगेन रिलीज्ड. पहले तो यूसेज इसकी ज़्यादा हो गई कूलिंग प्रोसेस के अंदर, कूलिंग वाटर की, एंड देन एट द सेम टाइम उतना ही वाटर जो है वो रिलीज भी कर दिया. सो दिस इज हाउ वी आर कंटिन्यूसली एक्सप्लॉइटिंग आवर वाटर. हमारा इतना ज़्यादा वाटर जो है वो सरफेस वाटर की फॉर्म में अवेलेबल है जो कि हम इन प्रोसेसेस के लिए यूज करते हैं. सो व्हाई नॉट वी रीसर्कुलेट, यही पानी जो है इसको आप रीसर्कुलेट करें आफ्टर ट्रीटमेंट एंड देन वी कैन हैव अ मच मोर सेविंग ऑफ द वाटर. Separate handling of different kinds of wastewater in order to reduce volume of wastewater. Reuse of industrial wastewater as input water. Elimination of the intermittent emissions of the process wastewater. ये वो ऑप्शंस हैं जो कि हम अडॉप्ट कर सकते हैं. सो सबसे पहले जो है वो क्या है जो कि हमने पहले बात की थी कि हर टाइप का, हर काइंड का वेस्ट वाटर अलग अलग हैंडल किया जाए. क्योंकि उसकी जो कंसंट्रेशन ऑफ कंटेमिनेंट्स है वो डिफरेंट है, उसकी ट्रीटमेंट मेथड जो है वो डिफरेंट है। We need different treatments for different kinds of sources. So अगर हम इसको प्रॉपरली मैनेज कर पाए तो हमारी जो ट्रीटमेंट कॉस्ट है वो बहुत ज़्यादा रिड्यूस हो पाएगी। सो ना सिर्फ कि ट्रीटमेंट कॉस्ट रिड्यूस होगी, बल्कि एट द सेम टाइम हम उस पानी को इजीली दोबारा से यूज़ कर सकते हैं इन डिफरेंट प्रोसेस, even in cooling process, even in a process as a process water हम उसको कर सकते हैं। So this is the best option. अभी हम क्या प्रैक्टिस करते हैं, हम सारे का सारा वेस्ट वाटर एकदम से डिस्पोज करते हैं इन आवर ट्रीटमेंट प्लांट। ऑफ डिफरेंट काइंड्स ऑफ वेस्ट वाटर, बहुत सारे डिफरेंट काइंड्स ऑफ वेस्ट वाटर जो है प्रोड्यूस हो रहे हैं, हमने पहले भी बात की है। फॉर एग्जांपल cooling water may be withdrawn from a nearby river, while processed water may depend on uh, municipal potable water. But even more so, it is important to separate the wastewater streams. While the most polluted water should be subject to a thorough cleaning, less polluted water may achieve a less thorough treatment or maybe even no treatment at all. This will in practice reduce the volume of wastewater. So process water क्या है? Part of chemical or physical production process. Processed water may contain very specific components, pollutants which require specific treatment. In some industries, processed water may be very large volume. So it is required to reduce the cost for the used volume of water and to reduce the amount of pollutants in the water. In a wastewater treatment plant, it is possible, independent of incoming concentration, to reach a specific residual concentration in the waters. So the processed water है, it is coming from different chemical and physical production processes, और इसके जो कंपोनेंट्स हैं वो भी डेफिनेटली स्पेसिफिक होंगे। ये बहुत सारे जो इंडस्ट्रीज हैं उनमें ह्यूज क्वांटिटीज के अंदर प्रोड्यूस हो रहा है। सो व्हाट इज रिक्वायर्ड, एक तो ये है कि कॉस्ट जो है फॉर द यूज्ड वॉल्यूम ऑफ वाटर वो रिड्यूस की जाए। सेकेंडली, टू रिड्यूस द अमाउंट ऑफ पोल्यूटेंट्स इन द वाटर। Now it is only possible uh, to reach a specific residual concentration in the clean water. इसलिए नॉर्मली प्रोसेस वाटर को आप सेपरेटली डील करें ताकि उसकी जो ट्रीटमेंट है वो भी स्पेसिफिकली उसकी जो कंटेमिनेंट्स हैं उनके अकॉर्डिंग। दिस इज वन ऑफ द टाइप्स। इसमें ये एक इम्पॉर्टेंट फिगर है, इसमें हमारा फोकस है कि कंटेमिनेंट जब फ्लो के साथ मूव करे तो व्हाट इज इट्स सिग्निफिकेंस। दिस इज द फ्लो ऑफ इनफ्लो, दिस इज द आउटफ्लो, this is the initial concentration and this is the final concentration, and this is the amount separated pollutants जो प्रोसेस के अंदर यूज हो गया। उसके बाद हमने जो उसमें से कितना जो कंटेंट है जो मटेरियल है पोल्यूटेंट्स का वो सेपरेट किया जा सकता है। तो a simple equation expresses how the amount of separated pollutants depend on wastewater flow. This m is dependent upon this f, and then a low flow, अगर हमारा फ्लो जो है वो कम होगा और उसके अंदर जो कंसंट्रेशन है वो ज़्यादा होगी, दैट मीन्स हमारा होल प्रोसेस जो है वो लेस वॉल्यूम के साथ रन होगा। We need lesser design parameter, design specifications. हमारा जो रिएक्टर है that will be smaller, उसके अंदर जो रिक्वायरमेंट्स हैं those will be smaller. हमारी कॉस्ट ओवरऑल उसकी जो ऑपरेशनल कॉस्ट है वो रिड्यूस होगी। सो जितना फ्लो ज़्यादा है उतना ही बड़ा हमें यहाँ पे सेटअप लगाना पड़ेगा। और in the end we are not sure whether we are getting sufficient amount of pollutants in the end जिनको हम सेपरेट करें। सो रिक्वायरमेंट क्या है कि फ्लो जो है वो स्मॉल हो और जो कंसंट्रेशन ऑफ पोल्यूटेंट्स है वो ज़्यादा हो, ताकि हमारा जो ओवरऑल ऑपरेशनल कास्ट है और जो उसकी इंफ्रास्ट्रक्चरल कास्ट है वो रिड्यूस हो गए। So this is the strategies through which we can obtain a better result and we can have saving in terms of now please go through the cooling water, sanitary water. It is on the same pattern, storm water, and elimination of intermittent emissions in batch manufacturing process. The emission of wastewater also comes as batches. This could lead to problems with intermittent loads on the treatment plant and the recipient with respect to concentration of pollutants as well as amount of wastewater. Therefore, so there are at least two ways of reducing this effect. ये वो चीज़ है जो जिसकी हम अभी थोड़ी देर पहले बात कर रहे थे कि एक तो यह कि बैच रिएक्टर का इशू है that we are collecting waste water in different timings, जो कि अब तकरीबन ऑब्सोलीट हो गया। हमारा फ्लो बहुत ज़्यादा है, हमारा जो वेस्ट वाटर फ्लो है उसकी क्वांटिटी ज़्यादा हो गई, सो वी नीड कंटिन्यूस फ्लो। तो पहली चीज़ है। दूसरा ये है कि उनकी जो कंसंट्रेशंस हैं वो वेरी करती हैं, बिकॉज फॉर एवरी फ्लो देयर विल बी डिफरेंट कंसंट्रेशन। पहले बैच के अंदर ज़्यादा कंसंट्रेशन आ गई पीएच की, पोल्यूटेंट्स की, पीएच की वैल्यू हायर आ गई। अगले बैच में कंसंट्रेशन लो आ गई, पीएच वैल्यू भी लो आ गई। तो इस तरह के जो इश्यूज हैं उनको नॉर्मल फ्लो इक्वलाइजेशन टैंक इन आवर वेस्ट वाटर ट्रीटमेंट प्लांट्स, जिसका बेसिक मकसद फ्लो को बैलेंस करना, जो उसकी करेक्टराइजेशन है उसको होमोजीनियस करना, ताकि एक ही लेवल के ऊपर आगे ट्रीटमेंट प्रोसेसेस जो हैं वो प्रोवाइड किए जा सके। बट इन केस ऑफ बैच रिएक्टर आप देख सकते हैं कि वी हैव डिफरेंट काइंड्स ऑफ डिफरेंट कंसंट्रेशंस हैं जो कि हमें मिलती हैं। हाउ टू डील विद दैट? चेंज द प्रोडक्शन so that the frequency of the emissions is increased. प्रोडक्शन का रेट जो है उसको चेंज करें ताकि हमारी जो एमिशन है वो भी आगे जाके वेरी करें, thereby decreasing the emitted amount at each emission. So अगर प्रोडक्शन एक लेवल पे ज़्यादा होगी, that means जो वेस्ट जो कंसंट्रेशन है वो ओवरऑल रिड्यूस होगी, बिकॉज अगर आप बैच वाइज करेंगे तो सारी कंसंट्रेशन पहले एक्यूमुलेट होगी, फिर वो आगे जो है वो डिस्पोज होगी। लेकिन अगर आप उसको वेस्ट वाटर प्रोडक्शन को ज़्यादा कर देंगे तो दैट मीन्स द कंसंट्रेशन हैज़ रिड्यूस्ड, हैज़ डिक्रीज्ड। कंसंट्रेशन तो जो बैक एंड पे सेम रहनी है, लेकिन हमने उसका फ्लो जो है वो उसको उसकी टाइमिंग को इन्हांस किया है। वी हैव इंक्रीज द नंबर ऑफ टाइम्स दिस फ्रीक्वेंसी, ताकि हमारा जो concentration of effluent है वो reduce हो। Then collect the wastewater in a tank and from there release it at a mean speed to the wastewater treatment plant. This is what we call flow equalization tank, कि हमारी जितनी भी characteristics हैं वो एक ही जैसी हो जाए, homogeneous हो जाए। Then we move forward. Now एक और हमारे पास term है that is about process चेंज। उसके अंदर हमारे पास जो प्रोसेस चेंज टू रिड्यूस वाटर कंजम्पशन और हमारे पास कुछ केस स्टडीज हैं फॉर वाटर कंजर्वेशन. So process change to reduce water consumption. Generally, most efficient way to decrease the amount of outgoing wastewater is process. First of all, a substantial recirculation of processed water is an alternative to decrease the amount of fresh water required. ये हम चीज़ पहले डिस्कस कर चुके हैं that there should be an integrated approach. हमने डिफरेंट एरियाज का जो वेस्ट वाटर है उसको रिसर्कुलेट करना है. On a substantial recirculation of the process. This is what we were talking earlier that हमने प्रोसेसेस को इंटीग्रेट करना है. एक प्रोसेस का जो वेस्ट वाटर है वो दूसरे प्रोसेस का सो इस तरह से हम जो वेस्ट वाटर प्रोड्यूस हो रहा है उसको रिसर्कुलेट करना है एंड देन वी विल reduced water consumption as well. Prime problem is to avoid the build-up concentration of pollutants and byproducts in processed water to unacceptable levels. It may be avoided by cleaning the processed water after each cycle. An example is the water in a paper mill which passes the paper when it is formed. एक और हमारे पास जो उसका solution है that is by maintaining good housekeeping. आप बुक चैप्टर को अगर आप फॉलो करें, you can have a detail of these good housekeeping. Then we have two cases for water conservation. Process for chlorination of hydrocarbon. This is a process. इसमें conventional absorption of HCl with water जो है जो कि conventional technique है absorption of HCl with water. न्यू प्रोसेस क्या है कि एडियाबैटिक एब्जॉर्प्शन जो है वो विद इवेपोरेशन ये हमने अडॉप्ट की है. देन वी हैव अनदर एग्जांपल जिसमें नाइट्रेशन ऑफ हाइड्रोकार्बन्स उसका जो अर्लियर प्रोसेस है वो भी बताया गया एंड देन द न्यू वन इज which through reuse and recirculation of the remaining products and unreacted raw material leads to a decreased environmental hazard potential in wastewater. So please इन दोनों processes को ये दो flow charts हैं actually इनको go through करें और इनके ऊपर thoroughly work out करें how by process change we can have water conservation strategy. So this is all for today's lecture. आप प्लीज इसको thoroughly go through कीजिए. असल में जो कंटेंट है ये सारे का सारा and I will request you to follow the book chapter rather than follow this presentation because इसमें बहुत सारी चीज़ें simplified हैं और just for the sake of information यहाँ पे रखी हुई हैं but the real knowledge is in the chapter. I will request कि आप please book chapter follow करें. So that's all for today's lecture. Furthermore मैं एक क्विज भी आज की डेट में आपसे शेयर